All right, welcome back, everybody, to Accuplacer Math Crash Course Day 1. We're on Part 2, just coming back from a little break. And we got another question on the board about the order of values here from least to greatest. Go ahead and read question number 14 for us, please, Juliana.
Which of the following correctly orders the values above from least to greatest?
Ooh, a little bit more complicated here, possibly. Because we got some percents here.
Oh, good old percents.
Oh, yes. Oh, yes. Okay. So a little bit, another just element of difficulty here. I think we're going to have to talk about percents before we answer this question. I think we're going to have to talk about percents. Juliana, what does the word percent mean?
Out of 100.
It means out of 100. Percent means per 100. And remember, right, like there's 100 years in a century. Right, this is where some Latin skills might come in handy. There are 100 cents in a dollar, right? So cent means out of 100. So percent means that number out of 100, right? Which is why like 50%, right? 50% is the same as 50 out of 100, right? If you got a 50% on a test, hopefully you did a little bit better. But if you did, ever get a 50%. I've gotten lower grades on many tests, but including math tests, boy. But anyway, I'm not going to talk about that here. I got to talk about my math credentials. But that's 50 out of 100 questions. You got right. 50%. Another way to express that would be if you actually punch that in your calculator. In fact, do that real quick. Punch in 50 divided by 100 in your calculator. Tell me what you get. 0.5. So those are all equal. Those are all equivalent expressions, right? 50% is the same as 50 over 100. Also the same as 5 over 10, by the way, or 10 over 20. Those are all equivalent. And it's the same as 0.5. Okay? Does that make sense?
Yes.
Okay. All right. So I think to start this, before we start ordering these values from least to greatest, I think we have to talk about what 0.75% means. What does 0.75% mean? And notice it's not 75%, it's 0.75%. So what does 0.75% mean?
75 out of 100?
75% is 75 over 100. Think about that for a minute. You got a 75 on a test, right? And this just lines up with common sense, lines up with what you know from experience. If you got a 75 percent on a test, it means, and say it's a 100 question test, you got 75 out of 100 questions right. But this isn't 75%. This is 0.75%. That's less than 1%.
Yeah.
Do you see that? 0.75 is less than 1, right? That's obvious?
Yes.
Yeah. So what 0.75% is, there's my decimal there, 0.75% is the same as 0.75 divided by 100. And that's very different. Does that make sense? Or no?
Yes.
Yes. Okay. Okay. So whatever the percent is, you just take that and you divide it by 100, and you get the equivalent value. Right? In this case, with 75%, we put 75 over 100. In case of 0.75%, take the 0.75 and divide by 100. 0.75%, by the way, is very, very small. Is that bigger than or smaller than 0.075?
I would say bigger.
Let's test it. Let's test it. Do you know how to divide 0.75 by 100? No.
Maybe.
Let's talk about dividing 0.75 by 10. Can we do that first? Okay. If we've got 0.75, we're dividing by 10. How do I do that? I mean, we could kind of set it up like we've set it up with the other, questions and the, there might be a name for this form. I don't know. It's just traditional long division form. We could kind of do that. right?
Mm-hmm.
In fact, let's start there. Let's start there. And remember, we're dividing 0.75 by 10 here, not by 100. Not yet. We're going to divide by 100 in a minute. But how do we do this? How many times does 10 go into 7? No times. So we got the decimal up here. No times. How many times does it go into 75? How many times does 10 go into 75?
7.
7 times. So 7 times 10, 70 minus 5, 0, drop the 0. How many times does 10 go into 50?
5.
5 times. 0.075. Make some space there on the whiteboard. Okay? Does that make sense? That's 0.75 divided by 10.
Mm-hmm.
Okay? So what I've done basically, I've inserted a 0. When I divide by 10, I just added a 0 after the decimal, but in front of the 75. So guess what I do when I divide by 100?
You put another 0.
You put another 0 in there. Absolutely. So tell me, what is 0.75 divided by 100 now? What's that going to equal?
0.0075.
0.0075. Absolutely. And we could go through the steps again if we needed to. But it's going to be the same thing. Basically, like if you're dividing by 1, you leave it, right? Because 0.75 divided by 1 is itself. But if you're dividing by 10, just add a 0 after the decimal, but in place of the 75. If you're dividing by 100, just put 2 zeros after the decimal and in front of the 75. Does that make sense?
Yes.
What if we were dividing by 1,000?
You put another 0.
Put another 0, right? That would be 0.00075. Absolutely. Does that make sense?
Yes.
Okay. Again, we don't have to worry about that because here in the question we're just dividing by 100 because it's 0.75%. So I'm not too worried about that. Okay. So let's answer the question now. Which of the following orders them from least to greatest? Before we even do that, I mean, let's look at the answer choices here. What can I eliminate right off the bat?
C.
C is gone, right? Because look at C. Look how silly that is. Because they put the 3/4 as the biggest one. We know that's not. That's just crazy, right? Without even knowing anything about percents, by the way, without even knowing what we just learned, you should be able to eliminate C right off the bat. Because 3/4 is bigger, much bigger than 0.075. It's also bigger than 0.75%. What else can we eliminate now?
B.
Yeah, B also, right? Because they put the 0.075 as bigger, right? We're ordering from least to greatest. Bigger than the 3/4, which is nuts. That's nuts. And again, maybe we should have started here. I apologize. We should have started here with the basic logic. We should have started there. You don't even have to, if what you watch those who watch the recording, if you just saw all the division we did and none of this is making any sense, you're just super confused. That's okay. Don't worry. Because using some basic logic, you should be able to eliminate B and C, no problem, because 3/4 has to be bigger than the other values. It has to be. So it can't be B or C. You're guessing I get a 50-50 shot. 50% chance of getting this right, which is pretty good on a tough question.
I would say A.
It is A. It is absolutely A, because we know that 75% is 0.075. Or 0.075, which is smaller than 0.075. So we can confirm it is indeed answer choice A. Yeah. Yep. Any questions about that, Juliana?
Nope.
Nope. Okay. I don't expect many of the least to greatest or greatest to least questions to get much tougher than this, especially with the percents that throw students off. But again, just remember, percent means that number divided by 100. And especially if you have a calculator, and I couldn't tell you whether you're going to have access to a calculator or not here. I don't know. If you have access to a calculator, just divide, on the Accuplacer, just divide the 3 by 4. You'll get 0.75. If it's 0.75%, just divide 0.75 by 100. You'll get what that's equivalent to. If they give you a calculator in here, this is a breeze. And they may. They may. Okay? Any questions?
Nope.
Let's keep rolling. Ooh. Go ahead and read number 10 for us, please.
What is the value of 3.85 plus 0.004 plus 0.1 1.7.
Oh, a bunch of decimals. So we're adding decimals here. Do you know how to, this here, we're going to have to do, estimation is not going to be super helpful, I don't think.
Yeah.
Although there's one answer choice I think right off the bat we could eliminate. What answer choice could we eliminate? D is nuts.
D is ridiculous.
It's ridiculous, right? Because 0.004 is very tiny, and 0.117 is small, really small. It's about a tenth.
Mm-hmm.
It's really, so you got 3.85. Again, think in terms of money, it's $3.85. And you're adding like something less than a cent and something like 12 cents. You're just going to have something a little bit over 3.85, which is either A, B, or C. But it's not D. So even if this is as far as you get, you've improved your odds of getting it. You've improved your odds of getting it. But I think the operation's pretty easy here. When we're adding decimals, just make sure the decimals are lined up and then just add like you would any other number. Do you know how to do this? Could you work this out?
Mm-hmm.
Let me see you work it on the whiteboard.
Yeah, I'm going to start out with the 0 decimals.
Great, that's fine. It doesn't matter.
Any way you add it.
Yep, doesn't matter the order. I would add them all together though, right? Like just line them all up.
Yeah.
Yeah, and then the key thing, I just want to make sure everybody watching the recording sees what she's doing here. She's lining up the decimals. The decimals have to be lined up when you're adding here. There you go. As long as you line up the decimals and everything is in the same place, you're good. Excellent. Yep. Looking good, looking good. Let's add them. It's 11. Put the 1 in the next place. Absolutely. 1 plus 1 plus 5 is 7. Absolutely. So in the next set of numbers. 1 plus 8 is 9. Absolutely. There you go. What's the right answer?
C.
Absolutely. Absolutely. Any questions there?
Mm-mm.
I'm guessing this is the kind of question they wouldn't give you the calculator for on the Accuplacer, just because if they gave it to you, then you're just punching them in. But
yeah.
But it's not too bad. Yeah, it's just basic. And again, if you don't know how to add numbers, I mean, I recommend doing a deep dive on YouTube about adding decimals. I want to show you how it's done here, just to remind you. The key is keep those decimals lined up. But
yep.
if you know how to add that, it's not too bad. Okay, are we good?
Mm-hmm.
Let's do some more. Oh, number 16. Go ahead and read it for us, please.
Oh goodness.
Yeah.
What is 0.8637 rounded to the nearest hundredth?
Ooh, round to the nearest hundredth. Round to the nearest hundredth. Okay, we got to talk some vocab here.
Yeah.
Okay? So we're talking decimals here. And to get this one right, you just have to know what they mean by the hundredths place. The hundredths place. Now, I know if we had to give us a number that said round to the nearest 100, I know you know what that is. I mean, that's 100, right? Here's 300. Where's the hundredths place? Right here.
Mm-hmm.
Right. That's easy. But hundredth, we're talking about to the right of the decimal. To the left of the decimal. Turn to the right of the decimal. Okay? So let's talk about what that means. So we've got a number. Well, in this case, it's 0.8637. Let's talk about the places here. Okay? Let's talk about the places here. This right here, this 8, that's the tenths place.
Mm-hmm.
The tenths place. Okay? Tenths place. There's no like oneths place. That's not a thing. Okay? It's the tenths place, right? Because 0.1 would be 1/10. Right? 0.1?
Mm-hmm. Yes.
Is 1/10, right? You divide 1 by 10, you'll get 0.1. Divide 2 by 10, you'll get 0.2. So 0.2 is 2/10. Does that make sense?
Yes.
That's why it's called the tenths place. Okay? If you take 8 and divide it by 10, you'll get 0.8. So it's 8/10. Okay. Guess what this next place is called?
Hundredths.
That's the hundredths place. Apologize for the wretched handwriting. Hundredths place. Okay? And by the way, that's the one we're looking for here. Right? It's after 10, right? Hundreds after 10, so it makes sense.
Mm-hmm.
Guess what place this is right here, in case they test you on it?
Thousandths.
Thousandths. Right? Absolutely. And what's this place right here?
10,000.
Absolutely. 10,000ths. I don't expect them to get that complicated.
Yeah.
Oh boy. Whatever. 10,000. Oh boy, that is just terrible handwriting. Please forgive me. All right. Okay. But yes, the 10,000th place. Okay. But here that's just round this to the nearest hundredth. So how many numerals are we going to have after the decimal point? How many numbers are we going to have after the decimal point? If we're rounding to the hundredths place.
1.
No, that would be the 10th place.
2.
2. Right. It's gonna be right here, to the left of that. Okay? That's what we're rounding it to. Okay, now, here's the deal. When you're rounding numbers, the question is it going to stay 6? Is it going to be 0.86? Or is it going to be, we're going to bump that up? All right, it's going to be 0.7, because it could be 0.87, depending on the numbers that follow the 6. Are we going to round up, or are we going to round down here?
We're going to round down.
We're going to round down, because the number that follows right here, right, that 3, is less than 5. If it's 5 or greater, we round up. If it's less than 5, we round down, which I think makes sense, right? Because 5 is and above is relatively close to 10.
Yeah.
You know what I'm saying? But if it's less than that, you're closer to nothing, for sure. So now if that were 0.685, we would round up. But it's not. It's 0.863, so we round down. What's the answer, by the way?
A.
It's A. Absolutely. Right. And you know that before you even do any rounding, just by knowing what the hundredth place means. You know you can eliminate 2 answer choices, right? What answer choices?
B and C.
B and C are gone. And maybe I should have started there. Again, I probably should have. Right? Before I got too technical. Common sense. Common sense here. If you know what hundredths means, that's the second number after the decimal, then it can't be B or C, because those are in the thousandths place. So it's either A or D. The question is, do you round up or round down? Look at the next number. That's it. If it's 5 or bigger, you round up. If it's less than 5, you round down. And that's all there is to it. But even if you didn't know that, as long as you know your places, tens, hundreds, thousands, 10,000s, etc., 100,000ths, all that, then you can eliminate half of them. It's no problem. Any questions?
Nope.
All right. Let's keep rolling. Lots of arithmetic here. More arithmetic. I think that's mostly what we have today. Okay, we're going to get this. We got this. This is not bad. This is not bad. Go and read question number 1, please.
Which of the following fractions is equal to 0.06?
0.06. Okay, let's think in terms of basic logic and common sense. Let's start there instead of ending there this time. Let's start there, Juliana. Let's think about money again. 0.06. How much of a dollar is that right there?
That's 6 cents.
That's 6 cents, right? And if you literally want to place a dollar sign there to help you think in those terms, great. So which of the following is equal to 6 cents? Okay. Let's look at the answer choices. Is 1/6 of a dollar 6 cents? No. No, 1/6 of a dollar would be how much? Roughly. Give me an estimate. 1/6 of a dollar.
Shoot, I don't know.
I mean, like, if you have a dollar and you split it into evenly amongst your 6 friends, how much is each friend getting, roughly?
Depends on how much I want to give them.
Well, it's like you're giving them all. Fair point. Let's say you're giving them all. You're not basing it on how much you like each friend. You're basing it. We're communists here. We're communists here, and we're distributing everything equally, regardless of merit. How much would each friend get? I mean, would it be 6 cents or more?
It would probably be more.
It'd be more. Not a ton more, but it'd be more than 6 cents. That's all you need to know. Yeah. I mean, it'd be more than 10 cents, right? Because if you had 60 cents and you divide it equally among 6 friends, they each get 10 cents, right? I'm just trying to make this concrete. But if you've got a dollar, you've got even more. So it's going to be close to, it's going to be 18, 17 or 18. I don't know. I don't even care. It's not 1/6, right? It's not 6 cents. Does that make sense?
Yes.
What about B? No. Is that more or less than 0.06?
That's more.
1/60th is going to be, well, is 1/60th of a dollar?
No.
Is that, no, that's going to be like less than 2 cents, right?
Mm-hmm.
Which it is. That's not too much. It's very tiny. I mean, 0.06 is small, but 1/60 is even smaller. Does that make sense?
Mm-hmm.
I don't like that. What about answer choice C?
Mm-mm.
Is that bigger or smaller than 0.06?
I think that's bigger.
It's bigger, right? Because 0.6 of a dollar, it's more than half. Right? 5/10 would be half.
Yeah.
Does that make sense? So 0.6 of a dollar, that's like 60 cents. In fact, that's exactly what it is. 60 cents is 0.6 of a dollar.
Mm-hmm.
Which even feels right too. Does that make sense?
Yes.
We can eliminate C. I sure hope D works.
Mm-hmm.
Is 6/100 bigger than, smaller than 0.06, or is it equal to 0.06?
Equal.
It's equal to. Absolutely. And this kind of ties in with the last question, right? That 6 is in the hundredths place, right? 0.06, right? The first 0 is in the tenths place. The second, the 6 is in the hundredths place. That is 6/100ths. 0.06 is 6/100ths, and this is also 6/100ths. 6 divided by 100. Mm-hmm. I mean, we could go through the division thing. Do we want to do? Do we want to do it? Do we need to do that again?
Nah.
I think with the sort of the basic logic, at the very least, we can eliminate A, no problem, and C. C is way too big. B might be reasonable-ish, but again, if you think about it in the right terms, it's just not.
Yeah.
0.06. It's smaller than 0.06. So we confirm it's D. Yep. Any questions?
Mm-mm.
Okay. I think we're good there. Again, think about the weight of these values. The weight of the values. Think about it in concrete terms.
Mm-hmm.
Let that guide you. It's better than any operation. Again, you could divide 6 by 100 and you'll get 0.06 if you do it right. You could divide 6 by 10, you'll get 0.6. You could divide 1 by 60, you'll get something. It's really small. I don't want to do that. I think we're good. Okay. Question 15. Go ahead and read it for us, please.
What is the value of 2.84 times 3.9?
Before we do the math here, before we do all the steps, let's see if we can solve this using some basic logic and basic estimation. Okay?
Mm-hmm.
What value is 284 close to? 2.84, I'm sorry, I should say. 2.4.
2.8. Wait.
Yeah.
Oh, it's close to 3.
It's close to 3, right? If you got $2.84, you almost have $3.
Mm-hmm.
Right? If you're like, how much did that thing cost? I bought a drink at Starbucks. How much did it cost? Right? And you wouldn't be like, it was $2.84. And you'd be like, it was like $3. Right? Does that make sense?
Mm-hmm.
What about 3.9? What's that close to?
Yeah.
What's that
4.
close to? It's close to 4. So we got something close to 3 multiplied by something close to 4. Right? Right? What's the answer probably going to be close to?
Probably close to 12.
Probably close to 12, because 3 times 4 is 12. It's going to be close to 12. That little squiggly, the squigglies means roughly equal to.
Mm-hmm.
Close to 12. Probably a little bit less than 12, right? Because 2.84 is a little bit less than 3, and 0.39 is a little bit less than 4. Mm-hmm. So it's going to be close to 12, but probably a little bit less than 12. OMG, look at the answer choices. What's the answer, Juliana? Yes. Absolutely. Absolutely. Absolutely.
D is ridiculous.
D is ridiculous.
Also
Heck, C is ridiculous. Heck, A is ridiculous. If you know what 3 times 4 is. Mm-hmm. Which hopefully you do.
Yes.
If you don't, you should probably rethink college. Okay. There's still hope. There's still hope. But I'm assuming anybody watching this video. There's 3.4. There's 3 times 4s. But that's it. Just logic, man. At least for this one. You don't have to do the steps. I'm guessing, though, this is the kind of calculator, or the kind of question on the Accuplacer they might not give you a calculator for. Okay. Mm-hmm. If you had to calculate it, doing the steps, Do you think you could do it?
Mm-hmm.
This is a test. I'm just testing your middle school arithmetic here. Let me see if you can do it. I'll guide you through it. Now here, when we're multiplying decimals, you don't have to line up the decimals. You just have to keep track of how many numbers are to the right of. You don't have to line them up. In fact, I wouldn't. I wouldn't line them up. Yeah, just shift it over. If you wanted to, you could. But when you're multiplying, you don't have to line them up. I'll show you why in just a moment. You just have to keep track of how many numbers are to the right of the decimal. And in this case, there are 3 numbers that are to the right of the decimal. All right, so hold on, stop. I want to make it really clear to anybody watching this kind of what's going on here. You're taking all these values and you're going to start with a 9 here. And you're multiplying 9 times 4, and then 9 times 8, and then 9 times 2. Okay, so hold on. Let me stop you real quick. I just want everybody to follow along. You're doing great. You're rock and rolling here. What's 9 times 4?
36.
36. So you put the 6 down here below the 9 and the 4, and then you put the 3 in the next place over. And you're going to multiply 9 times 8. Now,
72.
Which is 72. I'm glad you knew that. I didn't know immediately offhand. Maybe I should rethink college. But anyway, yes, 72, and then you add the 3. So what's 72 plus 3?
75.
75. So you put the 5 down below that. And then the 7 in the next place. Just keep shifting it over. Absolutely. And what's 3 times 2 is what?
6.
6, and then 6 plus... Is that a 7? That's a 7, right?
Mm-hmm.
6 plus 7 is what?
11.
I don't think it's 11. 6 plus 7.
Wait. 13.
13. Use your fingers if you need to, and I'm dead serious. Again, I'm such a fan of making this stuff concrete. Absolutely. Okay. Now, don't worry about the decimals here. We're not there yet. We're not there yet. We're going to get there. Okay. But don't worry about the decimals yet. Not when you are multiplying. I'll explain. We're going to get to them at the end. Right now, let's just crunch the numbers. All right, so we've got the 9 done. Now what do we do? Before we multiply that 3 and that 4, what do we have to do?
Put the decimal point?
Not there. We're not there yet. We're not there yet. We actually have, because we're moving to the next place, we have to put a 0 right here.
Mm-hmm.
We have to put a 0 right there. Because now we're multiplying by, not by 9, we're multiplying, really, in a sense, by 30. I know we're multiplying by 3, but anyway, when you go to the next place over, you got to put a 0 in that first place on the right-hand side. And multiply, okay, so 3 times 4 now is what?
12.
It's 12. Let me clear some space up there for you. 2, and then put the 1 up there. What's 3 times 8?
24.
24 plus 1 is 5. And again, if you're watching the video here and you're just completely confused about what's happening, do a Google search on multiplying decimals. And, it's just not really within the scope of this course. I'm assuming you have some handle on it. Okay, 2 times 3, 6 plus 8. There we go. Good. Now, let's add them all together. 6 plus 0 is 6. 5 plus 2 is 7. 3 plus 5 is 8. And we did something wrong. What did we do wrong?
I don't know.
Let me double check. I'm going to run through this real quick.
Mm-hmm.
9 times 4 is 36. 75. Looking good there. 7. 9 times 2 is 18. Oh, that should be that 9 times 2 is 18 plus 7 should be 25 in the numerator, right here. That should be 25. I think so. Let's double check. Let's try adding the bottom together. This is why I just love the basic logic approach and not the going through the steps. It's so easy to make silly mistakes. I make them all the time. In case that's not obvious. There we go. There we go. That's 11. Okay. Excellent. Okay. And I'm going to leave this in the recording. Like, and I just want to like encourage anybody, like, if you are struggling with the operations, hey, there's so many steps, there's so many things to do, and it's easy to lose track of things, but you don't have to know how to do it to find the right answer. You don't. Not here. You don't have to know everything. You just have to know enough to find the right answer. And we found it without doing a single calculation.
Yep.
And that's the way to approach this test, man. If you can think in those terms, you're golden. You're golden. Don't be intimidated by this. Focus on what you know. You know 2.84 is close to 3. You know 3.9 is close to 4. Use that. You know the answer is close to 12. It's got to be B. Okay. Now, once you've added all those numbers together there at the bottom, you've got to count how many values are to the right of the decimal place. And here you've got 0.8, 0.4, 8, 4, 9. So you've got 3 values to the right of the decimal place. So that means you've got to shift your decimal over 3 places, 1, 2, 3, which is exactly what you did. 11.067. We can confirm it's indeed answer choice B. Ah! It's just like, that's tough for me. I mean, I can teach this stuff for a living. And I make silly mistakes. And, like, you know, like, but you don't even know that. So I really recommend the first way, in case that's not obvious, just estimating using logic. But if you want to do it, you want to confirm it, that's how you do it. I really like the first way. All right. Number 12. Go ahead and read it for us, please. I know. This is like a middle school arithmetic nightmare. All this stuff. It's like the most annoying concepts for middle school arithmetic altogether in one place. All right, go ahead.
What is the remainder when 599 is divided by 9?
Do you remember remainders?
Middle school math.
Yeah. Do you remember remainders? Do you remember that thing?
Is it those top numbers when you do the long division?
I mean, it's like if you're not going into decimals, it's like what's left over. Like it's basically saying how many times does 9 go into 599? And we're going to find out how many times. We're going to just divide them. We're going to find out how many times 9 goes into 599. But instead of getting into the decimals, we're gonna stop and see how much is left over after we've put 9 into 599 as many times as we can. That's the remainder. That's the thing about it. Remainder means what's left over. Right? Mm-hmm. Like if you have like leftovers after dinner, the leftovers are your remainder, what's left over after you've eaten it all. Right? So it's what's left over after you've divided 599 by 9. So let's do it. Let's divide 599 by 9. I'll get it set up here on the whiteboard. 599 divided by 9. Let's go through it. 9 doesn't go into 5 any times. But how many times does 9 go into 59?
6.
6 times, right? So 6 up here. 6 times 9 is what?
54.
54. Subtract them, and we get 59. How many times does 9 go into 59?
6.
6. Right. 6 times 9 is 54. Same thing we just did previously. Let me scroll down a little bit here. Yeah, subtract them. Absolutely. You're one step ahead of me. And you get 5. Now, hold on. Does 9 go into 599 more than 66 times? No, it does not. I mean, we could start doing decimals. So like a fraction of 9 can go into 599 after 66, but it goes in fully 66 times. So the remainder
is 5.
Is 5. And that's your answer. It's just what's left over. So you just kind of know that concept. Mm-hmm. I don't know if they would give you a calculator in this question on the Accuplacer. If they do, just see how many times 9 goes into 599. I mean, find out how many whole numbers.
Yep.
You know, if it goes in 66 times, multiply 66 times 9, which is going to be, I don't know, 594, I guess. That's what it's going to be. Mm-hmm. And see what's left over. Right? Subtract that. You know, it's 599 from 594. I think. Does that make any sense, Juliana?
Yes.
The remainder is what's left over after you've put in as many times as you can. Yeah, that's the remainder. Okay. But at the very least, like, it doesn't, I'm trying to see if I can approach from like another, like, basic logic standpoint. There might be a trick to it that I'm unaware of at the moment. But,
I think if you looked at it on a calculator, the remainder would be like 66.5 repeating, and that would be the remainder.
I don't know if it works that way. I don't think it does. I could be wrong. I don't think so. I think you just have to, you just have to see, like, go through the steps and see. Or, like I said, like, multiply 66 times 9 and get whatever that is. Again, that's going to be 594. 66 times 9. And then just subtract 599 from 594. And that'll give you 5, which is the remainder. So technically, when you write it out, you go, remainder 5. This is middle school math here, man. Remainder 5. Or at least that's how I learned it. Remainder 5. Any questions?
Nope.
Okay.
Word problem.
Word problem. All right. Go ahead and read it for me.
A store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 of the cans were sold. What percent of the cans of popcorn were stocked What percent of the cans of popcorn were sold that weekend?
Ooh, okay. All right. What are we solving for here, Juliana?
The percent of cans of popcorn stocked were sold that weekend.
The percent of cans of popcorn that were stocked, that were sold on that weekend. Okay, let's stop. Okay. Let's go back to the rules for mathing. We got to read rule number 1 and 2. Read rule number 1 for me again. We just got to refresh this.
Use basic logic and estimation whenever possible.
Okay. Basic logic and estimation, and then rule number 2.
Use process of elimination to test answer choices whenever possible.
Let's do it here. I just need to emphasize that. I just had to emphasize it. Because it's tempting to go right into the math. And I don't want to. I want to start with basic logic. I want to start with basic estimation, start getting rid of some bad answer choices here. So we've got 150 cans of popcorn for sale. They sell 72 of them. Don't do any math here. Roughly what percent were sold? Tell me. Roughly. Without doing any math. I don't want to hear any numbers being crunched here. Just roughly what percent? Roughly what fraction? Or I'll take a fraction. Is it half? Is it more than half? Is it less than half?
It would definitely be less than half.
It's less than half. It's less than half. Right? Does that make sense? Because half would be 75. So it's got to be less than 50%. Right? 50% is 1/2. It's the same thing. So just knowing that, we can eliminate an answer choice. What answer choice can we eliminate?
D.
D, because that's more than half. D's gone. Adios. No me gusta. Respuesta de. No me gusta. Okay. So that's gone. Are there any other answer choices you think you can comfortably eliminate?
I think we can eliminate A.
Absolutely. 2% of 150? 2%, right? I mean, like, think about it. It's a 150 question test. And you got 2% of them right. Like, how many questions did you get right? If you got 2%.
Small amount.
What's that? A very small amount. Like 3 of them. I think it actually might be 3. I don't really care. But it's really small. We're talking 72 out of 150. Which is almost half of them. Does that make sense?
Yes.
It can't be A. We're not doing a calculation here. We're just thinking about what these things mean. 2% means 2 out of 100. Come on, man. We're talking 72 out of 150? 2% is way too small. What about answer choice B? 5%? Are you kidding me? Right? Like 72 out of 100 is close to 50%. 75 would be 50%. So it's a little bit smaller than 50%. What's the right answer?
C.
It's got to be C. That's without doing a single calculation. Common sense, basic logic, process of elimination. This is how you do this freaking test. Don't complicate it. Don't complicate it. Does it make sense when I talk about focusing on what these things mean?
Yes.
If you understand what percent means, you're good. 2% means 2 out of 100. We're not talking about 2 out of 100. We're talking about 72 out of 50. It's almost half of them. Half is 50%.
Yes.
It's got to be C. Which it is. Okay. Let's go over the math here real quick. I'm guessing they would give you a calculator for this one. I'm guessing.
Probably.
If you wanted to calculate what percent 72 is of 50. If you want to calculate that. I'd say test the answer choices. Like, let's find 2% of 150, and find 5% of 150, and find 48% of 150, and 72% of 150. I think that's the best way to do it, instead of setting up an equation. Because we can set up an equation, I don't want to do that crap. Let's test them. So if you want to find 2% of 150, all you got to do is multiply 150 by 2%. And remember, 2% means 2 out of 100. What's 2 out of 100? You can just punch that in your calculator. What's 2 divided by 100?
0.02.
0.02. What does that give you? What does that give you? What's 50 times 0.02? 150 times 150 times 0.02.
3.
3. I was right. What's 150 times 5%? What's 5%, by the way?
0.05.
0.05, absolutely. Right. Again, just divide 50 by 100. And that'll tell you what the percent is. 50 divided by 100 is, 5 by 100, is 0.05. What's that? What's 150 times 0.05?
7.5.
7.5. No, we're not selling any half cans of popcorn. What is, what's 150 times, 48% is what?
0.48.
0.48, absolutely. Just multiply by the percent. What's that?
72.
72, bingo. We can confirm it. That's it. I mean, we can multiply 150 times 0.72, we'll get something bigger than 72, which is silly. Again, it's not half. Or it's not bigger than half of 150. So, any questions about that?
Nope.
I still like the basic estimation, the basic logic approach. You don't have to get technical. It's the best way to do it. Oh, Manuel. What is Manuel doing? Go ahead and read number 7 for us, please. Manuel is making life complicated for us. Go ahead and read it.
If Manuel deposits 25% of $130 into a savings account, what is the amount of his deposit?
Let's talk about basic logic first. Okay? Let's talk about basic logic. What's 25% mean? What does that mean?
25 out of 100.
25 out of 100. 25 out of 100, which is like 1/4. In fact, it is. Mm-hmm. Right? Does that make sense? 25. I mean, like, it's 25% off, right? You're paying 3/4 of the original price, but you're taking off 1/4 of the price, right? And again, this is where you tap into your experience of life and your common sense. Okay? He's depositing 25%. It's 1/4 of $130. Give me an estimate here. What is 1/4 or 25% of 130? Don't even look at the answer choices. Don't even try to do a calculation. What would 1/4 of that be? What would 25% of 130 be? What would it be? Roughly.
Like 25-ish?
25-ish, yeah. Maybe a little bit bigger than 25.
Yeah.
Close to it, right? Because 25% of 100 would be 25. Mm-hmm. Right? It's a little bit bigger than 25. Maybe 30, 35, something like that.
Yeah.
Okay. Look at the answer choices. There's 2 answer choices that aren't even close. Mm-mm. What answer choices can we eliminate?
A and D.
A and D are just ridiculous. Come on. 25% of 130 is not 5. It's ridiculous. Ridiculous. And 25% of 130 is not $97.50 is more than half.
Yeah.
Of 130. That's crazy. Does that make sense? Why those are so silly? B and C are reasonable at the very least. And if you're going to guess between B and C, what would you guess?
C.
Probably C. Probably C. If you did, you'd be right, because I know it can't be B. Again, 25% of 100 is 25. Let's do the calculation here, though. Okay, how would we find 25% of 130? What would we do? 130 times what?
0.25.
Times 0.25, because 25% is 0.25. Again, 25% means 25 divided by 100. And if you divide 25 by 100, you get 0.25. So just multiply by 0.25. What do you get when you multiply 130 by 0.25?
32.50.
32.50, which is answer choice C. But again, we could get that pretty much just by using basic logic as well.
Yep.
It just feels right, doesn't it?
Mm-hmm.
Just feels right. You can use your intuition here on this test, man. You can feel your way through these questions, at least on the arithmetic section, and some of the algebra, which we'll get to later.
Yeah.
Use your common sense. And if you get something, if you crunch some numbers together, you get something that violates your common sense, you're like, that doesn't sound right. It's not right.
Mm-hmm.
It's got to work in the real world.
Yep.
So a couple more. Number 17. Go ahead and read it.
60% of what number is equal to 30?
Ooh, 60% of what number is equal to 30? What are we solving for here, Juliana?
What number is equal to 30?
Yeah.
60%.
Yeah. What 60% of some number is equal to 30? Okay, stop for just a minute. Stop for just a minute. Before we do the calculation, before we do the operation, you understand what the question's asking you. 60% is close to like 50%, right?
Mm-hmm.
I mean, and I think people are generally more comfortable with like 50% meat, like that. People know what that means. It's like half, right? So like something a little bit bigger than half of some number is equal to 30. Just look at the answer choices. Juliana, what's the answer?
C.
No.
Oh.
No. If you take 18 and you find 60% of that, right?
Mm-hmm.
Is 60% of 18 going to be bigger than 18 or smaller than 18?
Smaller.
Smaller than 18. Right?
Is it B?
If you take 2 and you find 60% of 2, is that going to be bigger than 2 or smaller than 2?
Smaller than 2.
Smaller than 2. That's not 30.
I'm kind of leaning towards D now.
You should be leaning towards D, right? Think about it. Again, you got to think about what it means, right? I mean, does it make sense? Does it make sense? We're talking about 60% of some number, right? We're cutting that number, almost in half.
Mm-hmm.
Almost in half. 60% of some number.
Yep.
We're cutting the number in half. And if you cut these numbers in half, if you cut 0.5 in half, that's so small. Right? I mean, it's already less than 1. You cut it, you take 60% of it, it's even smaller.
Uh-huh.
B is silly. You take 2, cut it in half, you're going to get something around 1. But you got to get 30, right? Because we're 60% of what number is equal to 30. Does that make sense?
Yes.
I think just in terms of basic logic, you got to pick D. If you're thinking about it in the right terms. Now, where were you getting thrown off? I'm curious. Where were you getting thrown off?
I think I was just kind of like choosing the random answer choice.
Okay.
I didn't really think about it logically.
Okay. Does it make sense now?
Yes.
Why you can think about it logically?
Mm-hmm.
Okay. And if there's something you don't understand, if I'm going over this and I'm like, it's something you don't understand, even if I'm like, it should be really obvious, and you're like, and you don't understand, just say you don't understand. Like, I don't mind you not knowing. Like, there's a lot in this. There's much more in the world I don't know than I do know. So I don't mind you not knowing at all. But I got to know what you don't know so I can explain it. So don't worry if you don't know. And that's the same thing for anybody watching these recordings. Like, if there's something you don't understand, man, reach out to me. Just leave a question in the comment section. I check all that stuff. So just throw me a question. I'll be happy to explain as best I can. Yeah, I don't mind you not knowing. Not a bit. Let's talk about the operation here. All right? If I wanted to find 60% of answer choice A, what would I do? To find 60% of...
You do 0.6 times
0.5.
Yeah.
Which would not be 30. I think we can recognize that. Same thing with answer choice B. What would we do?
0.6 times 2.
Yeah, it'd be 2 times 0.6. Also not going to be 30, right? What is that out of curiosity?
1.2.
1.2, yeah. Not 30. Answer choice C?
That's 10.8.
That's 18 times 0.6 is 10.8, not 30. Again, you can test them all. If you want to find some percent of a number, just multiply the percent by the number. 60% is the same as 0.6. So multiply the number by 0.6. And then let's try to confirm answer choice D. 50
is 30.
There you go. Answer choice D. Any questions?
No.
Let's do a few more. You know what? I think I'm going to stop. Am I going to stop? I think I'm going to stop. I'm going to save this one for homework. Let me look over the questions real quick. Yeah, I'm going to save the others for homework. Yes, that is what I'm going to do. Okay. So I'm going to send you, Juliana, I'm going to send you the questions we worked on today. I want you to practice those on your own. Okay, and this is true for anybody watching the recording too. If you sign up for the full course, please do the homework. You've got to do the homework. It's going to be the key to your success. You got to practice thinking in these terms. You got to practice it, and if you put in the work, you're going to succeed. If you put in the work, you're going to succeed. So try the questions that we've done today, and try to approach them the way we've approached them in the class today. Again, using basic logic, common sense, estimation, and using that process of elimination. Try solving it the way we solved it in the class. If you don't know how to solve it, then watch the videos and go back and review the solution. I'm going to have some new homework questions for you, just a couple of them, okay, that I'm going to send you. I'm going to email to you, Juliana, directly. So check those out. And if you don't know how to solve any of them, don't worry. We're going to go over them all at the beginning of day 2 of the course. Okay?
Yeah, I'll try to do them as best I can.
Okay, and if you can't, no big deal. That's okay. No problem. We're gonna, we'll go over all of them on the day 2 course. Okay.
Okay.
Do you have any questions for me, Juliana?
Nope.
No. Okay. Awesome work today.
Thank you.
Yeah, appreciate your participation and your hard work, and I will see you next week. Okay.
Okay.
Okay. Thank you so much, Juliana.
Bye.
All right. See you soon. Bye.